Okay, so new unit. So unit 3, this is 3.1, representing relations. Okay, so you guys did a bit of this kind of stuff before, and just to kind of show you where we're going with this. Remember grade 9 how we had like that y is equal to mx plus b equation, and we were like drawing lines. Yeah.
I don't believe I was here for that.
Yeah, you were. We're gonna do more of that type of stuff, and these are considered like relations, and then we're gonna get into like functions. Okay. So relations are just how things are related. Like I know that sounds like almost overly simplistic, but in a relation is an association or relationship between two quantities or variables. That's the very like mathy way of saying it. But a relation can be represented in different ways. So we could have it represented like this with ordered pairs, they're called. So we can say 2 is, so if I have like a 2 that's related to 25, a 4 is a 19, a 6 is an 11, and so on, right? And then a closed bracket like that. So we'll do some more examples like that. Another way of doing it is with an arrow diagram. So you could have like everything in this set is related to everything in this set, and you just draw like an arrow showing how they're related. So 2 would go to 25. 6 and 8 both end up giving me 11, right? So that's just like another way of relating that one. Or you can have a table of values, so x and y values. We did this in Math 9, right, with the table of values, where you could have your x's and your y's. All right. These things can also be represented. These different relationships can be represented on a graph, right? So, in this case, number of cards versus number on card, right? So, those could be different relations as we go, where you can like plot the data. We could have bar graphs showing the data. There's lots of different ways to kind of show different relationships between data. Okay. All these different methods, though, some are going to be better than others. Like, for example, like if I'm looking at this table of values and I want to see, let's say, like maybe they've found some sort of like, data to suggest that, schools are a really big transmitter of COVID or something, right? Like if that's the case, then we can have data for that, right? And you could show that, and you could throw that into like a table, right? Where you could have like schools and like how many of them get COVID and everything else, right? I get kind of lost in the numbers though, right? And that's why sometimes it's a lot easier to have like graphs, and you guys have seen that too, right? Where they'll show like graphs of like how these things are portrayed. And sometimes like, the bar graph is a better way to like visually see that thing, and sometimes these are a better way, right? So there is no right way. There's just kind of like a more appropriate way to visualize it sometimes.
Why does COVID get brought into every conversation?
All right, so we look at this one. The famous artist and inventor Leonardo da Vinci studied the proportions of the human body. One of the relations he measured was the proportion of the length of the ear to the length of the face. Why would Leonardo da Vinci be interested in this? The relation he discovered could be presented in a variety of ways. Okay, so in words, you could say he found that the length of your face from chin to hairline, yeah, sorry, this is like the guy who wrote this, Dr. Light, is equal to 3 times the length of your ear. Okay, so what you could do is you could write that as an equation, right? The length of your face would be equal to 3 times the length of the ear. Okay, so then as an ordered pair, we can write that out. We could say, okay, well, if the length of your face, the length of your ear was 4, then your face would be 12, right? Just times 3. Does that make sense? 4.5 would be multiplied by 3 to get 13.5, right? Each of these numbers is just being multiplied by 3 in this case, but that is their relation, right? You could say that for any length of your ear, you could always figure out the length of your face.
So how do you get from 4 to 4.5?
These are just random numbers. These numbers are just somebody's length of their ear was 4, and somebody else's was 4.5, and somebody else's was 5.
6.5? Aw, damn.
Yeah. Actually, it wouldn't matter for centimeters. Well, I guess if, yeah, these numbers going in, but this could, yeah, yeah. Okay, so we could also write that in a table, right, where we could have those same values down the side, and we could have the length of the face going this way, or we could draw it as a graph, right? And the graph is actually a bit more valuable here. You can really directly see that relationship now, can't you? A straight line. It's like directly related. You get that a nice straight line going on, right? All right. Now, so I'll let you guys do this one. So animals can be associated with their classes, or with the classes they are in. Describe this relation in words. It's just going to be the class that animals belong to. Like, it just seems like overly simple, right? Like, so don't overthink those ones. And then represent the relation as a set of ordered pairs. I will be okay if you guys write this out like shorthand instead of writing out the whole word for every one of them. But here, yeah, so let's go as a set of ordered pairs. You would make a squiggly bracket first. That was terrible. Everybody try their best to make a squiggly bracket. This is a tough skill.
I did it. I just put some squiggly. Isn't it just a backwards 3?
Sure.
Yes.
not quite, but
What do you mean not quite?
there's it's not quite.
It's like a bird, like the weird bird you used to draw, and like.
Oh yeah. Okay, so our first relationship here is just going to be and the class that it belongs to, right? So you can write in the whole word ant if you like, or I'm okay with going more shorthand, where you could say like an or something, comma, and then maybe in for insecta, and then close the bracket, and then comma, and then do it again. So then we'll just move on to the next one. So eagle and aves. So EA, comma, AV, and then another comma,
Oh, wait, what?
and then snake, so maybe SN, comma, capital RE.
How do you know like what abbreviations to use?
Well, I'm just gonna make it up.
Oh, is that what
So
you
you,
do?
you can always make them up.
Yeah, as long as I know that you.
But like,
I'm just being lazy. You could write the whole word and put the whole word in there. I'm just trying to make it easier on all of us. So you could do TU for turtle
Title.
and
that'll
RE for reptilia, and then for whale, WH, and then for mammal, I'll write mam. Okay, and then don't forget, you're going to have to do a squiggly bracket on the other side of that one.
I can't just be bracket.
If any of you guys are into like wanting to get into coding or anything, a lot of what we're doing right now is kind of related to a lot of that. This would be like considered an array in coding. So it would show up a lot more if you ended up doing that. Okay, as an arrow diagram, so an arrow diagram would just be we'd write them all out, so it'd be like AN. Eagle would be EASN TU WH, and then we just kind of like circle them like that, and then write out all the other options here. So IN AV.
do they have to be beside their insect? Like,
No, because we're gonna draw arrows. It won't really matter. Like we'll just in the end here. So RE and then MAM.
would we need 2 of these?
No, we're okay with just one. We'll just have 2 arrows going to it.
Oh.
Yeah, so so for ant, that'd just be straight across. Eagle would go straight across. Snake would go straight across. And then turtle would also go up to reptilia. And then whale for mammal. There you go, arrow diagram. And then technically you probably should have animal, like have these labeled. So animal and class.